Hello, today we're going to talk about financial mathematics. So, at some point in your adult life, you will either need to invest or borrow money. And in this case, the person who lends the money to you will be called the lender, and you will be known as the borrower. The amount of money that you borrow is what we call the principal. And most lenders charge you a fee, which they call interest. This is the cost of using their money. The rate of interest is usually expressed as a percentage of the principal and is known as what we call the interest rate. So let's talk about compound interest. When money is deposited into a bank, it will usually earn compound interest. After a certain amount of time, which is called a period, the bank will pay you a certain amount of interest. The value of a compound interest investment after n time periods will be equal to your future value of your money or your account being equal to your present value times 1 plus your interest rate divided by 100 times the number of times or compounding periods per year raised to the power of k times n, which is the total number of times that you will end up receiving that compound interest over the entire period of time. So let's look at some examples. $4,000 is invested for 6 years at a rate of 9% per annum interest compounded annually. So I want to figure out what will the value of the investment be at the end of the period. So I want to know the future value. So the future value will be equal to the present value, which is 4,000, times 1 plus my rate is at 9%, divided by 100 times 1 because it's compounded once a year annually, to the power of 1 times 6. So I'm going to enter that into the calculator exactly how I have it here. So that's going to be 4,000 times 1 plus 9 divided by 100 times 1 is just 100. And we're going to raise it to the power of 1 times 6, which is just 6. And we end up getting that this account should be worth approximately $6,708.40 at the end of these 6 years. So the next question is asking how much interest has been earned. So interest is how much the bank paid. Okay, so basically it's your total value, which is $6,708.40. And we got to subtract the amount of money that you invested yourself, which will give us the interest of $2,708.40. Number 2, it says, how much does Savion need to invest now so that his investment will be worth $15,000 in 7 years' time? Given that the interest rate is 6.5% compounded biannually, give your answer to the nearest dollar. So we know that the future value of the investment, we want it to be $15,000, but we don't know how much he wants to put in now currently. We need to find PV. So what we're going to do is we're going to say 15,000, which is the future value, is going to be equal to PV, which is the present value, times 1 plus 6.5% compounded twice a year or biannually. So that's going to be divided by 100 times 2 to the power of 2 times 7 because it says 7 years. So in order for me to solve for PV, I need to divide both sides by what I'm multiplying PV by. So here I can say PV is approximately equal to 15,000 divided by 1 plus 6.5%. We know that 100 times 2 is 200 to the power of 2 times 7, which is 14. So when I do that, I have 15,000 divided by 1 plus Make sure you put in your fraction. 6.5 over 200 to the power of 14. And we will end up seeing that he needs to invest approximately $9,586 because it says round to the nearest dollar. He needs to invest this amount in order for it to grow to $15,000. So now let's talk about inflation, the real value of an investment, and depreciation. So inflation is the general increase in the price of goods and services over time. Inflation reduces the purchasing power or buying power of your money because the fixed amount of money will buy less goods and services as prices continue to rise over time. To understand how well an investment will perform, we will have to consider the final value in terms of today's purchasing power. This is called the real value of the investment. Depreciation is the loss in value of an item over time. And when we talk about inflation and depreciation, majority of the time it is compounded annually, one time a year. So with that being said, we have the exact same formula as we did for compound interest when we deal with inflation and depreciation, except because it is compounded annually, we normally have K being equal to 1. And we know that when we multiply by 1, nothing changes. And then we also see that we can have plus or minus because your values can go up or your values can go down. So let's look at a few examples. Example number 3, it says, Michelle would like to purchase a gold necklace currently worth $3,000. She makes monthly deposits into an investment account so that she can purchase the necklace in 2 years' time. If the inflation averages 3.75% per year, calculate the value of the necklace indexed for inflation for 2 years. So basically, we're saying that the value of the necklace is going to appreciate over time. So we can say that our final value is going to be equal to the present value of the gold necklace, which is $3,000, times 1 plus, because the value is going up because it says it's going to be indexed for inflation. Then we have 3.75 divided by 100 to the power of n, which is 2 years. So we literally type that into the calculator exactly how it is. And once we do that, we press enter and we see that the value of that necklace in 2 years will appreciate or go up to $3,299 and approximately 22 cents. Number 4, Kamari invested $1,500 in an account for 5 years at 7.3% interest rate compounded quarterly. Inflation over the period averaged 4% per year. So part A says to calculate the value of the investment after 5 years. So we want to find our final value. So our final value is equal to 1,500, which is currently what he put in, plus 1 or times 1 plus 7.3 divided by 100 times 4, because K is 4, is compounded quarterly, 4 times a year, to the power 4 times 5, because 4 times a year over 5 years. So I'm going to have 15,000 times 1 plus 7.3 divided by 400, because 100 times 4 is 400, to the power of 4 times 5, which is 20. And we will see that the future value of that account is approximately $2,153 $0.67. So the next part says we want to find the real value of the investment. So remember, the real value is basically what is that amount of money going to be worth down the line? Okay, what is the amount of that amount of money going to be worth? So remember, money over time, things go up. Okay, there's a saying that everything increases in price but wages or pay, because your pay normally stays the same while everything gets more expensive. So remember, your real value of the investment is basically looking at your future value in terms of today's money. So what we are going to do here is we're going to put in that our future value, of course, is $2,153.67. And we want to find the real value of it. Like, what is that amount of money 5 years down the road? What amount of money does that look like today? Okay. So we're going to have times 1 plus, it says the inflation rate is 4%. So we're going to have 4 over 100, and it's going to be over a period of 5 years. So when you type it into the calculator, be very careful. So when we type it in, we are going to have that our present value is going to be equal to $2,153.67. And I need to divide it by 1 plus 4 divided by 100 to the power of 5. So when you put it in, press alpha y equals 2,153.67. And we're going to divide it by 1 plus 4 divided by 100 to the power of 5. Okay, and when we do that, we will end up getting that this money is approximately worth, or the real value of that money is worth $1,770 and approximately 16 cents. Okay. So basically, the real value of that money is $1,770.16, which is less, because that money is going to be worth less in the future. All right. So let's look at number 5. A car was purchased for $18,000 and depreciated by 12% each year. What is the value after 6 years? So if I want to figure out the value after 6 years, I can say that my future value of the car is equal to what I paid for, which was $18,000. And you have to subtract from 1. You have to do 1 minus 12 over 100 over the course of 6 years. So literally, we're going to type it in exactly like this. And when we do that, we see that the value of the car will be approximately $8,359.27 after 6 years. The next part, it says, by how much did it depreciate? So we can take the initial value of what we paid for it and subtract the value that it went to, or that it was. And that difference will give us how much it depreciated. So if I do 18,000 minus $8,359.27. I will end up getting that it depreciated by $9,640.73. All right. So now let's show you how to use technology. So anytime we use technology, you have to understand that most calculators have a finance program that helps with solving finance problems. This program is called a TVM Solver. TVM stands for time value of money. So to get to the TVM Solver in the TI-84, we are going to press Apps, and then we are going to select Finance, and then select TVM Solver. And you will end up getting the screen that is in your notes. So before you can put these numbers in, you have to understand what they mean. So N represents the number of compounding periods. I represents the interest rate per year. PV stands for the present value of the investment. PMT stands for the payment each time period. FV stands for future value. P/Y is the payments per year. C/Y is the number of compounding periods per year. And your PMT can either be chosen to be at the beginning or the end. And majority of the time, we use and we pay interest at the end of the time period. So we're not going to do anything with the PMT portion at the end. So let's look at example number 6. So Michaela invests $25,000 into an account that pays 4.75% compounded monthly. How much is her investment worth after 8 years? So remember, 8 years and it's compounded monthly. That means that the total amount of compounding periods, or the total amount of times that this account is going to get interest payments, is going to be the number of years times the number of compounding periods. So we can say 8 times 12, and we know that 8 times 12 is 96. If you want to type it in the calculator, you can just press 96, or you can type in 8 times 12 and press enter, and it will simplify it for you. The interest rate is 4.75. So we are going to type in 4.75 here. The present value is how much she invested. And remember, if you invest money, that is currently money that you don't have access to. So it's like you are in the negative. So we're going to say negative 25,000 because that is money that you don't have anymore. You gave it away. Your payment is going to stay at 0 because you're not making a payment. And you don't know what your future value is. So we're going to leave it at 0 for right now. And then the payments per year and the compounding periods per year represents how many times the money or the bank is going to pay you out your interest. So they do it 12 times a year. And notice it will automatically change your CY when you change the P/Y. So in order for you to solve for the future value, you scroll up to where FV is, you highlight the cell, and then if you look at your calculator at the bottom by the enter key, you will see that it has the word solve written in green. This means that you are supposed to press alpha, enter, and it will solve it for you. So here it is saying that the future value is approximately $36,529.70. All right, let's look at number 7. Jalen is investing money in a term deposit account that is going to pay 3.2% compounded daily. How much does he need to deposit now so that he will collect $7,000 at the end of 3 years? So the interest was compounded daily. So that's 365 days times 3 years. And when we do 365 times 3, we end up getting 1,095. The interest rate is 3.2%. We do not know the present value, so we're just going to call that 0 because that is what we're trying to figure out. We're trying to figure out how much does he need to put in. The payment is going to continue being at 0. The future value of the account, he wants to be able to withdraw $7,000. And then we say that it's compounded daily, which means that he's going to get interest paid to him 365 times each year. And the same is for the C/Y. So we're going to go back up to the PV, press alpha, enter. And once we do that, we see that he should invest $6,359.27 in order for him to have $7,000 3 years down the road. Number 8. How much or how long should Dakota invest $6,250 at a 7.25% interest rate that is compounded half yearly for it to be worth $15,000? So we're trying to find N here. So I'm going to put 0 for N because I don't know it right now. The interest rate is 7.25. The present value of her investment is going to be $6,250. So I'm going to put a negative $6,250 because it's like she's giving the money away. The payment is 0. The future value, she wants it to be worth $15,000 in the future. And the interest is going to be compounded half yearly. So that means twice a year it will be getting interest. So once I do that, I can go up to N and I can press alpha, enter. And I end up seeing that N is approximately 24.6. And because N is 24.6, remember, it was compounded half yearly, so it was twice a year. So it was compounded a total of almost 25 times. So you would have to take 24.6 and divide it by 2 in order to see that that is equal to 12.3 years. So almost 12 and a half years. She would have to leave that money in there. All right. So I'm going to go back to my TVM solver for number 9. So number 9 says Orlandis deposits $5,000 into an account. So that means his PV is a negative 5,000 because he deposited or gave that money away. He doesn't have it anymore. And he says it's going to be compounded monthly. So that's 12 times a year for 3.5 years. So if we do 12 times 3.5, we end up getting that is 42 total periods. And the interest rate, we do not know what it is, so I'm going to leave it as 0 for right now. It says he's investing $5,000, so I'm putting negative 5,000 per PV. We're not making any payments. The future value of the account, he wants it to be $9,750. And we know that it is compounded monthly, so that means 12 times a year, which is the number of compounding periods per year. So now I can go up to the interest rate and press alpha, enter, and I will see that it's going to take an interest rate of approximately 9.2 in 3 significant figures. That is the interest rate in order for the amount of money to grow from $5,000 to $9,750 in 3.5 years, compounded 12 times a year. All right. If you have any questions, please feel free to reach out to me. I do not mind helping, and have a great day.